Welcome back, guys. Welcome to the channel once again. This side, Govind 3. Who is this side? Govind 3. And where you are watching this video in my YouTube channel, Chemistry Guru 1993. Right? So, welcome back, everyone. This time, last video I have uploaded lecture number 3 for the D and F block elements. In that case, the last slide was colors of some of the first row transition metal ions with the configuration, example and color is given. So that you have checked. Come to the next topic, formation of complex compound. Okay, formation of complex compound that we are going to discuss. In that case, what is written in the screen, you can go through it. That is the heading, formation of complex compound. Complex compound are those in which the metal ion bind a number of anion or neutral molecule giving complex species with characteristic properties like FeCN whole 6 minus 3, FeCN whole 6 minus 4, CuNH3 and like that. Complex formation is due to comparatively smaller size of the metal ion and their high ionic character and the ability of d orbital for bond formation, because we are having incomplete d orbital in the case of d block elements. Okay, that's why they are forming this type of complex compound. Next chapter based upon the complex compound only, so in detail we will discuss this compound in the chapter number coordination compound, guys. That is the important part, catalytic activity. So it's a important catalytic properties. The transition metals and their compounds are known for their catalytic activity, sorry. This is referred to their ability to adopt multiple oxidation state and to form complexes. Why it's happening? Because of multiple oxidation state and to form complex compound. These are the two special case. Sample vanadium oxide in contact process for the formation of H2SO4. Finely divined iron in Haber process for the manufacturing of ammonia, and nickel in catalytic hydrogenation. Some more examples I can give you if you want. So in that case, listen it carefully. What are the factors responsible for the catalytic activity of this D block element? Number one, presence of incomplete d orbital, presence of incomplete d orbital. Number two, large surface area. Large surface area. Number three, variable oxidation state. And number four, ability to form complex. Ability to form complex. So these are the regions. Okay, why these D block elements and their compounds working as a catalyst. So if we are talking about 3D series, one by one we will discuss. In 3D series, Scandium. Scandium. Never use a catalyst. Never use as a catalyst. Okay. Number one. Number two, titanium. Titanium, that is Ti, it is used as a catalyst. TiCl4 plus Al C2H5 whole thrice. C2H5 whole thrice. Okay. So combinedly, this catalyst is called, very interesting, Ziegler-Natta catalyst. Name of the chemist, Ziegler-Natta. Ziegler-Natta catalyst for HDP preparation, synthesis of polymer. Basically, you can say that used in the synthesis of polymer. Okay, vanadium V2O5, that you know, contact process V2O5, vanadium pentoxide. In contact process, it used chromium that is used like Al2O3 plus Cr2O3, that is used in aromatization. Uh, Manganese, number 4. So here MnO2 used for the preparation of oxygen. For the preparation of oxygen, it is used. Hmm? So there are so many uses. Iron is used. Fidelcraft reaction, anhydrous FeCl3, anhydrous FeCl3, Fidelcraft alkylation. Hmm? Nickel, copper used in aromatization, copper tube and heat. Hmm? There are so many uses for the uh, catalytic property of D block element. So I hope that is enough. Hmm? You know that PdCl2, CuCl2, that is, these are the also used as a catalyst. So that is it about the catalytic activity. The transition metal ion can change their oxidation state. They becomes more effective as a catalyst. For example, iron catalyzes reaction between iodine and persulfate ion. This one. An explanation of this catalytic reaction is 2 iron, 2I and I2, 2Fe plus 2, S2O8 and this one. So that is more explanation about the catalytic activity. Now the formation of interstitial compound. Interstitial compounds. Interstitial compounds are those which are formed when a small atom like hydrogen, carbon, nitrogen are trapped inside the crystal lattice of metal. That is called interstitial compound. Titanium carbide, Mn4n, Fe3H, VH, titanium H1.7. Interstitial compound, simple definition, children. Interstitial compound are those which are formed when small atoms like hydrogen, carbon, nitrogen are trapped inside the crystal lattice of metal. Which metal? D block metal. D block metal. The physical and chemical characteristic of these compounds are they have high melting point, higher than pure metal. They are very hard. Some borides approaches diamond in hardness, means just like hard, just like a diamond. They retain metallic conductivity. Metallic conductivity, they are chemically inert, no reaction. They are chemically inert. Again, this is important property, alloy formation. Alloy formation. So, you know, alloy mixture of two or more than two metals, that is called alloy. In an alloy is a blend of metal prepared by mixing components. Alloy may be homogeneous solids solution in which the atom of one metal are distributed randomly among the atom of other. Such alloy are formed by atom with metallic radii that are within about 15% of each other. The alloy formed are hard and have high melting point. Alloy of transition metal with non-transition metal are brass, copper, zinc, bronze, copper, tin. Okay, basically you can say what is written here. Check it once. Alloy is a blend of metal prepared by mixing the components. Alloy may be homogeneous solid solution in which the atom of one metal are distributed randomly among the atom of other. Such alloy are formed by atom with metallic radii that are within about 15% of each other. The alloy formed are hard and have high melting points, guys. So, in the beginning, I told you this is the chapter of theory only. So you have to pay attention. Important compound of transition element, oxide and oxoanions of metal. These oxides are generally formed by the reaction of metal with oxygen at high temperature. As the oxidation number of a metal increases, ionic character decreases. Remember what is they are saying? Number of oxidation number of a metal increases, oxidation number increases, ionic character ionic character decreases. In the case of Mn2O7 is a covalent green oil. Okay, so thank you children. We have covered all the property of d block element. In the next lecture, we will start compounds of d block element, and I will start with potassium dichromate K2Cr2O7 from the next lecture. So till that, thank you, all the best. Please watch the video, share the video. Thank you.